Very happy to do this, and also signed up for this before we decided where all of our individual team summits at Stitch Fix were going to be. So the particular team that I am with this week is in San Diego. So I woke up there this morning, was there through lunch, went to the airport, flew from 3 o'clock to 4:30, arrived here at 5:45 after the bar, etc. I will leave at 9 to go back, get the last flight, and finish up my day after midnight down in San Diego. But then I will wake up in San Diego. So that's not the worst idea in the world. I love San Francisco too, but it's nice to have some dolphins and beach and stuff. Cool. So Randy Shoup, thanks again, Jerry, for organizing this. This is really cool. So I'll tell you a little bit about me super briefly to color, sort of the kinds of experiences that, where these experiences have come from. So right now I'm VP of Engineering here at Stitch Fix, so welcome to Stitch Fix. I run all the internally facing software here. Patrick, the awesome guy in the back corner, he's raising his hand, runs everything that's customer facing. So if you're a customer of Stitch Fix, as I hope you are, as I am, and many people are here, everything you use as a customer, Patrick does, and you will never see any of my software. But my software does a bunch of the internal stuff, the buying teams, the styling, and all that kind of stuff. Before Stitch Fix, I was sort of a roving CTO as a service. I spent about 1.5 years helping out startups in the Bay Area, larger companies in Europe and Asia, do the kinds of things we're going to talk about, thinking through their technology organizations, their technology approaches themselves, trying to get organized and get more scalable, be more like Google and eBay. I used to work at Google. I ran engineering for Google App Engine, which is Google's platform as a service, like Heroku or Cloud Foundry or one of the other platforms you might be familiar with. And then earlier in my career, I was chief engineer at eBay for about 6.5 years, and I spent most of that time working on eBay's search engine. So if you've ever used eBay and you didn't find something, that was totally my fault. If you found it and we had it, then my team did a great job. Cool. So super briefly about Stitch Fix. Because it's a really cool place to work and it's a really cool service, but also because it motivates, again, a bunch of the lessons that we're going to talk about. So Stitch Fix is an online clothing retailer, and unlike most retailers that you don't shop. Like, you don't come to a physical store, you don't go to an online store like Amazon. Instead, you tell us the things that you like, and we send you clothes in a box that we think you're going to enjoy. So how that works is you fill out a pretty detailed style profile about yourself. It's like 60 or 70 questions. It might take you 15 or 20 minutes to fill out. Everything from your price preferences, your size, your height, your weight, your age, whether you're a parent, whether you like to show off your arms, hide your rear end, like all sorts of detailed information about yourself that basically answers the question, if there's somebody in your life that knows how to choose clothes for you, like maybe that's you, or maybe that's a spouse, or maybe that's a sibling or a friend, what does that person know about you? And we ask you that stuff. Does it make sense? Like, we ask you detailed stuff exactly so that we can choose clothes that you're gonna like. So you have filled that out. We are gonna send you 5 hand-picked items in a box. It will show up at your doorstep. You try them on at home. The ones you keep, you pay for. The ones you don't like, you return to us for free. And you send them back in the mail, and it works great. So how does that work from a technology perspective? So we actually have a bunch of personalized recommendations that we compute for every one of our clients. So every day we look at every piece of inventory times every client and compute a predicted probability of purchase. In other words, the conditional probability that if we send Randy this pink shirt, what is the likelihood Randy will keep it? Does it make sense? So 65% chance for this shirt, 47% chance for these jeans, 52% chance for these shoes. The jeans and the shoes are Stitch Fix, by the way. And so there's a ton of machine learning that goes into that. It's an ensemble approach like Netflix. And so we compute, again, these scores. Those scores are given to a human stylist. So we don't stop with just the scores. There's an actual human stylist, 3,500 of them all over the United States, and they're the ones that actually choose the 5 items that go in the box. And the humans add on all the things that the machines don't know. So like, you can ask for, hey, I'm going to an evening wedding in Manhattan, send me something appropriate. I'm like, the machine doesn't know how to deal with that at all, but the human does. Or the human can put together an outfit that's appropriate for you. The human knows more things about what software engineers in Silicon Valley might wear than maybe the machine would. All those kinds of things, the humans are great at. And again, we have 3,500 of them all over the country. Okay, so, but that's our model for everything. It's like we try to use the machines where the machines work best and the humans where the humans work best. So as part of that, we actually have 100 engineers in the organization that Patrick and I are a part of. We also have 80 data scientists and algorithm developers. And that ratio between 100 engineers and 80 data scientists is actually unique in the world. So I have yet to hear, I would love to hear the counterexample if it exists. So far, I have yet to find it. Certainly in e-commerce or retail, like we know all those companies and nobody has a data science team that's our size. That is a unique ratio, and what do we do with all those data scientists? Well, it turns out that if you're smart, it really pays off. So you can, no battery. Can I have the other, thanks. Patrick, do you want to, there are batteries in that cabinet right there. Cool. Yeah, so it turns out that if you're smart, it pays. So we use intelligence, and by which I mean PhD, astrophysicists and biochemists and experimental psychologists, to do all these things. So we think about what clothes we should buy, in what quantities, in what size breakdowns, in what warehouses should we store them, et cetera, at what times should we get them. We think about them in terms of inventory management, what things we should keep, what things we should clearance. Logistics optimization, about getting things to you on a particular date the least expensive way possible. Everything about those styling recommendations that I shared, so computing those personalized recommendations for every piece of inventory times every client, and then also more standard things like demand prediction. And unlike the virtual businesses that I've worked at most of my career, we're a physical business. We actually have physical warehouses. We physically take possession of the clothes. And that means we actually need to be pretty accurate about predicting demand. Does it make sense? Like when I worked at eBay, if we had twice the number of people come and use the marketplace, like that would be awesome. That is an operations problem of like just simply, racking more servers because we racked our own servers. But here, that would be a complete disaster. Does it make sense? Because now we have, like if we doubled are more than we predicted in terms of demand. Now we have 50% of our customers that we can't serve because we don't have the clothes for them, we don't have the people in the warehouses to get them where they need to go, we don't have the stylists to style them, etc. Anyway, so we need to be pretty accurate about that. And again, like I say, our whole model is have the machines do what the machines do best and have the humans do what the humans do best. Okay, so that's all about Stitch Fix. This question is the motivation for this talk. So I've given a bunch of talks about how we used to do things at Google and eBay and other places. I talked about microservices and how wonderful they are, which we will talk about. But also, when I was doing that CTO as a service gig, I would have tiny little startups go, all right, we're ready to do microservices. Tell us how you did them at Google and eBay. And I would say, that's an awesome question. I will tell you, and then you have to promise not to do what I say. Not because not because Google and eBay did it wrong, but because Google and eBay did it right for Google and eBay. Does it make sense? Like when you have a 15,000 person engineering organization as Google does, there are certain techniques and certain ways of organizing that are appropriate. That are not appropriate for when you're 5 people sitting around a conference table, right? So this talk is a bit the answer to this question of what should we do at what time. Does it make sense? Yeah. Cool. And by the way, what's the way to say this? I'm going to say it in the flip way. I know all this stuff, so if you want to ask me questions, this is for you guys, right? Like, I wrote all the slides, so like this isn't for me, it's for you. So please interrupt me at any time with questions. That's not rude at all. That's actually, I'm hoping that will give you more benefit out of it. Does it make sense? Yeah, because otherwise I'd still be on the beach in San Diego. Cool. All right, so this is probably familiar to people, but it's kind of worth thinking about. eBay, depending on how you count, is now on its 5th complete rewrite of its infrastructure. So it started famously as Pierre Omidyar, the founder, wrote in a 3-day weekend in 1995 over Labor Day the first version of eBay. He wrote it in Perl. Every item was stored in its own file on the file system of his laptop. Actually, probably there wasn't a laptop. It was probably a desktop machine, a tower or something. Anyway, so monolithic Perl thing, where he was just trying out this new crazy thing called the web in 1995. The next version of that was a monolithic C++ application, which at its worst was 3.4 million lines of code in a single DLL. You think you have a monolith. Ha! eBay was hitting compiler limits on the number of methods per class, which is 16K. That was not good. So something needed to be done at the time this was maybe 2000. I wasn't there yet, but they evaluated different other ways to go, .NET, Java, decided to go the Java route. So they broke up that monolith not into what we would call microservices, but what you might call mini applications. So there was an application for, for the selling pages, for the buying, a separate one for the buying pages, a separate one for, the search pages, etc., times 220 different applications. So they divided this monolith into, 220 different parallel applications. That was the version 3. Then there was a version 4, which was mostly about redoing the front end. And now nobody calls it version 5, but the current version of eBay is basically a polyglot set of microservices. Twitter has gone through a similar evolution. So they were famously, they started famously as a monolithic Rails app, which they called the monorail. Pretty awesome. They next took that monolithic Rails app, broke it up. The front end mostly in JavaScript, the back end in services, mostly written in Scala, and then now I think it's fair to characterize Twitter as a polyglot set of microservices. Amazon has gone through a similar evolution, so they're not so clean on their architecture generations as eBay and Twitter, but they started out as a monolithic Perl and C++ application, which actually you can still see if you go to some of the product details pages. So if you look at something that's relatively old, you might see in the URL Obidos, O-B-I-D-O-S, and that was the name of that monolithic Perl and C++ application. Lots of things that they still sell that they sold 20 years ago still have that in their URLs because SEO, right? So then Amazon went through a pretty serious re-architecture from 2000 to 2005. And it is not well remembered now, but Amazon wasn't actually doing that great as a business. But Jeff Bezos, like super brilliant, he said, you know what? I don't care how long it takes, but we're going to retool everything to be service oriented. And this was 2000 to 2005, and everybody from the outside was like, you're crazy, and he's not crazy, right? Amazon's pretty great in lots of different ways, very difficult to compete against because in many ways they are able to move faster than anybody else at their scale. Why? Because they did the stuff that we're going to talk about. So they're definitely they wouldn't even call themselves microservices, but they would call themselves services. Anyway, does this make sense? So there are a couple of things to take away from this. The first is basically no one starts, or I claim no one should start with microservices, but past a certain scale, which I will say openly, 1% of 1% of 1% of companies actually reach this point, but past a certain scale, everyone ends up with something that we would call microservices. Does that make sense? Yeah. So there is a certain scale of Amazon, Google, eBay, Twitter, Netflix, beyond which you just simply die of your own monolithicness if you don't break up into something that's like microservices. But before that point, and we'll talk about that for at least the first half of the talk, before that point, I argue that it's perfectly appropriate to use a more monolithic approach because microservices are solving scaling problems that you might not have when you're a 5-person company. Does that at least assertion make sense, even if you might not agree with it yet? That's what we're going to talk about. Cool.
So are you going to talk about what that tipping point is?
I am absolutely going to talk exactly about that tipping point.
Different kind of ways.
Yeah, so the question is, what's the tipping point? Yeah, that is the motivation of this talk. How to make the decision in a pragmatic way about whether you're starting to scale, whether you should continue to live in a monolith world or be more microservices or something in between. That's the goal of this presentation. And feel free to keep asking questions about it because that's what this is about. Great. Please.
Can you throw some light on the evolution of services in Google?
Can I throw some light on the evolution of services in Google? I could probably shed a little bit of light. To be honest, I don't have any personal experience with that transition because when I joined Google in 2012, they were already super servicey. One thing, I think we're not going to talk about it here, but we were talking about it a little bit ahead of time. Google has a very, all of these big companies have a very layered set of services. So it's not like there's one flat layer of services that are all at top level. Google has this multiple layers of stuff. So at a sort of large scale ecosystem like an Amazon or a Netflix or a Google, there's layers of things. I honestly don't know. I was not there enough to give you a decent story about how that transition happened. I will say this, that Google never really built one monolith. I mean, they built things that have since been broken up into smaller pieces. But one thing that we will say, and I'll just say it ahead of time, a search engine naturally breaks up into at least 3 different components. So if you're familiar with a search engine, even conceptually, there's the idea of a Google scale. So there's crawling the web, so there's the crawler, there's the indexer that builds the index, and then there's the query engine, right? So, I mean, everybody's nodding, like, that's that is a natural division. So a monolithic search engine is already going to be those 3 pieces. Does it make sense? So that already lends itself really nicely to a bunch of the properties we're going to talk about here. So they chose a nice model. Similarly, something like, well, I'll get there. I'll get there, but it's a good question. Anything else so far? Great, those are good questions, by the way. Excellent. So yeah, so one thing I think to take away from that evolution is nobody starts with microservices. Everybody past a certain scale ends up there. I like to say this, that if you don't end up regretting your early technology decisions, you probably over-engineered. So it is possible that there was some eBay competitor that instead of building the monolithic Perl thing, decided, hey, we're going to build this distributed system because 10 years from now, we're totally going to need that. And there's a reason why we've never heard of that company, right? It's possible that there was an Amazon competitor or a Twitter competitor that did the same thing. There's a reason why we haven't heard of them, because they spent all their time building technology that they didn't need, right? And I will say openly, like, it pains me as an engineer in my gut to build something that I'm gonna throw away, except that thing I'm gonna throw away probably is gonna last 2 or 5 years, and that's not a bad day's work. Does it make sense? Building stuff that solves my current problems now, recognizing openly that I will have a different class of problems in 2 years or 5 years from now, that's engineering, right? And even in the physical world, which has been doing this for way longer than us, software engineers, there's stuff that you build, like the wooden bridge that crosses the creek, and then there are structural techniques to build, I don't even know what it's called, but I just today drove over this huge bridge in San Diego that goes across from the mainland over to Coronado. It goes way higher in the sky than I've ever driven, thousands of feet in the air it seems, and why they do that is because the ships, San Diego is a huge port for Navy ships that are massive, and they have to be able to, there's no drawbridge that would work for them. So anyway, they have to build this huge arc bridge. Anyway, the techniques that the structural engineers did for that, they're not applying those techniques to building the wooden bridge, across the creek in Tahoe. Cool, all right. So I feel like still we have to a bit define what microservices are. I will define them very briefly. The micro in microservices is the scope of the interface. So I'm not a believer that a microservice has to be less than 200 lines of code. Somebody has to be able to rewrite it in an hour. That doesn't do it for me. That's not reality for me. But I do believe the micro in microservices, the value of it is that it is single purpose and that well-defined interface is modular. In other words, we were talking earlier using a bioscience example of let's imagine that there's an instrument and I say, hey, tell me I'm gonna get the terms wrong, but tell me the guy's insulin level, right? What is the level of insulin in the bloodstream, if that's a thing? 52. Well, there's probably a lot of complexity associated with figuring out what that insulin level is, but that's completely abstracted by that simple interface. What's the insulin level? It's 52. Does it make sense? So, by analogy, or continuing that analogy, a microservice is something where you can ask very simple questions of, where inside that microservice is abstracted away something that's potentially complicated. Does that make sense? Yeah. Cool. And so they're modular and independent. And one thing we're going to talk about later is one thing that we have learned now that the first time as an industry we started to do service-oriented architecture we messed up is the idea that microservices really need to have their own isolated persistence. So if you're storing stuff in a database, it shouldn't be like one database shared among a bunch of services. Instead, each service should have its own, conceptually, logically, its own database, right? Why? Because you shouldn't be able to have anybody come in through the back door and violate your interface and get at your data. And if that seems weird, think about a class. Like you build a class in your favorite programming language, and every member of the class is public. Like, that's like first year, trying computers for the first time kind of approach. And you learn quickly that that's not the way to do it, right? That's not abstracted. That's just a struct, right? So by analogy to properly abstracting away and encapsulating data in a class that you write like in your IDE, similarly microservices in order to be abstracted and encapsulated need to do the same thing. Does that make sense? Right, yeah, sure.
So in the example of crawler versus indexer, how would you isolate the persistence?
Yeah, so the crawler has a bunch of state that maintains about web. I'm not a web search expert. I am an e-commerce search former expert. But yeah, but the crawler for Google is maintaining a state about all the websites it's crawled and what to crawl next. Like that's completely abstracted away from something else. And then it produces, then its output, the interface, if you like, to the next thing is it produces stuff in Google Bigtable, which is this database that Google uses for freaking everything, including the index, and then the indexer is going to go and index that and turn it into the next thing. So you can think of that as a pipeline of crawler produces a bunch of data, which is an input into the indexing step, and then on the flip side, the query engine is like consuming that thing. Does that make sense?
So what the crawler produces then is shared between, like that persistence data is shared.
That is the interface. Yeah. Cool. And again, I'm not an expert at building web search engines, so there are many papers you can read on exactly that know it better than I do. Cool. Okay. Whoops. Oh. Great. So, question: are microservices the right solution to every problem? I think not. So, and we're going to talk about when you figure that out. Okay. So here's the sort of outline of the talk. So I want to talk about monolithic architectures, when they are appropriate, what are their characteristics. I want to talk about microservice architectures, what are they good for, what are their characteristics. I want to talk about, Rolf's question, when and how to decide to re-architect, and then some tactics about doing that re-architecture. Does that make sense? Okay. So let's talk about monolithic architectures. So we like to say, we maybe feel bad, oh, I built this monolith, I feel so shamed. But there are lots of pros to a monolith, right? When you're getting started, it's really the simplest way to go. So it's very simple, everything is in one place. You have in-process latency, so the different components in your system are all talking in process. Typically there's a single code base, a single deployment unit, and then actually at small scale it's quite resource efficient, right? You just have one thing, you deploy it, you're good. The cons are, are all things that come with scale. So as your team grows, you get the same people, in the same code base and stepping on each other's toes, so there's sort of coordination overhead. There is poor natural enforcement of modularity, and I'm choosing all those words very carefully. It is very possible to build a well-modular monolith, like everybody who built things before the era of distributed systems did exactly that. You build stuff out of libraries, you put those libraries together, those libraries have well-defined interfaces. So it's absolutely possible to build modularity into a monolith. It's just, you have to do it through discipline. It's not, the process boundaries are helping you. Does it make sense? There's no enforcement of that beyond your own discipline. There are poor scaling characteristics, so typically if it's a monolith, the only thing you can do is go up. You can't divide it in half, right? And then it's also a single point of failure and a single sort of performance bottleneck. Does this make sense? Cool.
Basically, they are all in the same scope, right? So
They are all in the same scope.
Scope. Yeah, what I'm saying is that all the data, they share the same scope. That's why, you know, in monoliths, even though you build the module, right? But as you mentioned, right, it's
Yeah, I see what you're saying. Yeah, so what the question or the point is, the data is all in the same scope, so it's all accessible. Yeah, I mean, again, there are we built modular pieces of software for many years before we did distributed systems, so it's definitely possible, but it's not. Let's say it's not easy. You have to do it with discipline. Like you actually have to be disciplined about it. Yeah. Cool. So similar to, but slightly different from the monolithic application is the monolithic database. And so this is actually where Stitch Fix is. So we never built a monolithic application. We built a bunch of individual applications for the different domains that we serve, but we do have a monolithic database. And our struggle today, our work, our sort of technical investment, drawing down technical debt is like doing service extractions from this monolithic database. So again, the pros of one of these databases is it's really simple to get started. Join queries are really easy, right? All the tables are there. You just add another table to the from clause, you're good. Transactions are super easy, right? Because again, begin, insert into A, update B, commit. That's super easy. Like no problems there. And then again, at small scale, it's pretty resource efficient to have everything in a single database. But the cons, again, are cons that come with scale. With scale. So over time, everybody is in the database. So to use your point, there's one data scope, if you like. That's a good word, actually, which I'll probably borrow. It's also a performance and scalability bottleneck. So you will see, we certainly have had this issue at Stitch Fix where performance slows down for one reason or another of that shared database, and everything slows down. It is also, I think this is not as well appreciated as it should be, but it's actually pretty difficult to tune one database to do lots of different workloads. Does it make sense? So like 3 obvious flavors of workload that you probably all have in your systems are fast reads and writes of individual records. So that's kind of one class of workload. There are sort of join workloads that are about like putting together a bunch of different individual tables, and then there's also bulk reads and writes, so more for analytic systems. Anyway, so all those 3 workloads, you actually tune the databases in very different ways. People have done this before, right? Yeah. Those are all very different tuning kind of parts of the tuning solution space, and so that's challenging when you have only one database to deal with. And then also it's a single point of failure.
So can you work around so that by just partitioning the tables or sharding?
Can you work around it? If you can shard, you are already well beyond a monolithic database, right? So there are types of problems, and actually Stitch Fix has one of them, where it's very natural to shard by something. So I'll give you the Stitch Fix example. Our data naturally shards by customer. Yeah, our data science systems, use models that use data across all the customers, but the operational systems, we're operating on one customer at a time. And so for us, if we have not had to do this, but if we needed to shard, if we weren't solving the problem in a different way, if we needed to shard that database by customer, we could shard a lot of it by customer.
I mean, do you see a pattern where perhaps you keep your app monolith, you just maybe
shard your
decompose
data?
the database?
I suppose. I mean, I'd have to think.
Yeah.
There are many solutions to these problems, right? And the things that I suggest are not the only solutions. It is rare to find a problem it's rare to find a solution space that naturally shards by a single key. And by the way, even about Stitch Fix, there's only part of Stitch Fix that shards naturally by that, like the inventory doesn't shard by customer, for example. So in some sense, in most cases, in order to shard, you already have to have broken up your database into individual functional areas, in which case you should probably just slap services on them and call them microservices. And it's like different words for the same technique. Yeah.
So in terms of monolithic database, you mean just the traditional one giant system, single point of failure type setup?
What do I mean by monolithic database? Yeah, I mean if you can ever say the database, that's what I mean.
Yeah.
Right. So actually, one of the I didn't really intend this to be a thing, but like when I was like the roving CTO as a service guy, like, hey, tell me about your database. Like, oh yeah, the database, blah blah blah. Like, okay, that's a problem. That's in there. Like, all right, you already wrote part of my report there. By the way, as soon as you said the database, like, so many things are implied by those two words. And then and if you say the application, like, oh god, okay, here we are. Does it make sense? Yeah, but I'm not intending. I mean, feel free to ask more questions if I'm not answering it. But like, I'm not meaning to imply the database needs to be relational. I mean, it could be like there's lots of ways you can build COBOL in any language. Like you can build the monolithic database with any persistence technology. But yeah, but the typical thing is like, oh, it's some relational database and everything's in there. That's the typical case, but I'm sure there are others. Cool. Okay, so let's imagine we are in this, we're going to talk about microservices in a moment, but there are actually ways of improving the monolith even while you still have it. And so that first thing was sort of an answer to your question earlier about that kind of those natural sharding points. And so again, search engine is a good example of things that sort of naturally shard or naturally functionally partition. Other examples are like a car sharing service, like an Uber or a Lyft. Like that actually naturally shards by rider versus driver. Does it make sense? There's absolutely the Uber driver app. There's the Uber rider app. That's a natural point. I mean, they come together a little bit, but for the most part, those things are pretty separate from each other. And then a marketplace like eBay, it does naturally functionally partition by buyer versus seller for the same reason, right? The marketplace is where they come together, but there are tons of things that the buyers need to, tools that the buyers need that the sellers don't, and vice versa for the sellers. Cool. Anyway, so you should totally exploit that, right? If you're small, if there must be some startup that's going to try to beat Google, and like they're going to build the next cool search engine, and like they shouldn't close their eyes to the idea that they could, functionally partition it to the crawling, indexing, query side. But anything more than that when you're starting up is probably overkill. So the other thing I was talking about before is, we actually had componentization before distributed systems, before microservices, and you can totally leverage that, right? So you can build a monolithic application out of individual components, whether you call them DLLs or jars or gems, or like choose your language environment. But there's some way of building things out of these individual components that typically, have ways that you could abstract out the detail. And that actually allows the individual teams to kind of, I say, bound their cognitive load. Like they don't have to think about everything, they just have to think about like the particular library or gem or jar that they're building. Does it make sense? Yeah, so you can do that without putting a service boundary in there. Like you can do that without microservices. And then the other thing, this is maybe a little bit non-obvious, but I strongly believe it. Like, in order to improve a thing, you need to be able to iterate on it quickly. And so an investment in some flavor of continuous delivery and being able to, all the things that implies, automated testing, et cetera, allows you to rapidly deploy that monolith and make changes to it rapidly and safely so that you can keep breaking it up. Does that kind of make sense? Yeah. Cool. Okay. So that's about monoliths. Now I want to talk a little bit about microservice architectures, and then we'll talk about, deciding how to re-architect, et cetera. So as I mentioned, microservices are single purpose. They have a simple, well-defined interface. They are modular and independent. And again, as I mentioned, isolated persistence is something that we have learned is a real advantage. I like to say that there's nothing new about the concept of microservices. It's really just encapsulation, or another way to say it, it's just SOA done properly. And when SOA was done improperly, it was when we did not do that. We either built the sort of overarching services that were like, oh, this is everything about the buyer service. Like, that's not going to work at eBay scale, right? So we built services that were overbroad, or we had a bunch of services that seemed to be nice and cleanly separated at the top level, but they secretly shared all the databases and, not even so secret. Like that's exactly what eBay did, by the way, and it was a huge failure. So eBay made a bunch of investments in about 2008 into service-oriented architecture, and they built a bunch of services that had they were really well, they really built those interfaces very well, they were very modular, but underneath the hood, everything was all a set of shared databases. They were all partitioned and sharded and functionally separate, but they were completely shared. And so what that meant was services could, violate each other's interfaces by just going directly to the databases, and B, it meant that there was no incentive for the application teams to use the services because they could just continue using the databases that they used to do. Does it make sense? So yeah, the only way to make it work is the service boundary is the hard outer shell, and all the data behind that service boundary is isolated. Does it make sense? Cool. Okay, so microservices. So again, by comparison to the monolith, each unit in a microservice architecture is simple. There are many units, but each unit is simple. Each of them now have independent scaling and performance characteristics. So if I need to add more resources to the user service or the authentication service or whatever, I can do that independent of the other parts of the system. I think this is not as appreciated as it should be, but because we have built those things that are small and well-defined interfaces, we can now independently test and deploy them, right? So now it actually makes it easier to do things like continuous delivery because those individual services are simple and you can test them separately. Yeah.
So when you get to the level of having, 50s, hundreds, maybe even more, so microservices, and at which point for deployment purposes and enabling as many developers as you will then have, you'll be doing deployments all the time. You'll be shipping new code all the time.
Absolutely.
It also means that at no point in time can you say, well, we're running this version of the system. They're always having.
Yeah, absolutely right. Yes,
and you're probably doing canary deploys and progressively rolling out stuff and so on. So how to assert overall system correctness, or rather that the users of your system, whether that's other systems or an API or actual users or whatnot, are actually experiencing the user experience that you want them to have.
Yeah, okay. So just
asserting correctness on a whole system level.
Yeah, sure. So the assertion, which is correct, is that in a microservices ecosystem, there is no one version. There are just versions of individual components. You are probably deploying, at any moment, you are probably deploying one or several of them. Absolutely true. And so the question is, well, how do you determine overall system correctness? So I think there are two aspects to that. The first is, well, no, it's not that you don't. I mean, this is not a cop-out, but you do need to define what you mean by that.
Yeah.
And as soon as you define what you mean by that, then the answer starts to become clearer. So it may well be that the system correctness you're talking about is one particular externally facing service that your customers are interacting with, for example. In our example, it could be correctness could mean when a customer asks that we ship them a fix on August 29th, that it gets there at that time. And that might be the model. There's tons of stuff that has to happen underneath for that to be true. So you first have to define what you mean by that, but let's imagine you figured that out. The real aspect of correctness here is you need backward and forward compatibility of the interfaces of the microservices, right? So what you're trying to get to is a place where, I'm going to talk about this in a moment, but the way to get the microservice benefits of individual teams are able to move really quickly and innovate rapidly is they need to be able to deploy without talking to the other people, which implies that the deployment doesn't break the other people, which implies that the deployment is backward or forward. The thing I've deployed, I'm deploying version 12 of my thing. Version 11 is forward compatible with whatever I do in 12, and 12 is backward compatible to 11. Does it make sense? And so that allows me to be safe in deploying, my service, and that actually, if simply by that guarantee, you can guarantee that the overall system is at least healthy. So I don't know about system correctness. I'm not sure what we mean by that. We can talk about it. But does it make sense? Like, if what you're trying to do is, I want to have a stable system that it's not going, that isn't going down all the time, it's the sort of if and only if I have backward and forward compatibility of the interfaces, it will work. And you can use, semantic versioning to, to like reflect that or whatever. I feel like that's a little bit of an unsatisfying answer, but that is the building block upon which you can build overall system stability from individual components that are rapidly changing. Yeah. After him, but yeah.
Just to add here, like there is a testing pyramid in the microservice system where on the top you have end-to-end test, small number of, which test the whole like system from the user perspective. Then you have the integration test, where you test for the integration between the services, and then at bottom you have the unit test. So that way, like if you perform all of those three, your system is working fine.
Yeah, it's just that there is also a breaking point where any kind of end-to-end test involving all of your things will either be too costly because it's too large a thing to spin up in a particular configuration, or it evolves so quickly that you won't have the time to actually assert that. And so, at least one of my reflections currently having some of these conversations and so on now is, do we want to have, right now we have a situation where every change set goes through exactly that validation period. And we know that for this permutation of versions, this can coexist. And then there's, some slight period of time where it's out of sync. But it goes to a point where maybe the end-to-end stuff, you just want to verify that runtime rather than before building deploy time.
Yeah. So we could have, next time we have one of those cool conversations we can do with Mike. Let me try to reflect it back. So the point was made that it is difficult to test a large-scale system because many things are changing. That's one, and it might be too costly from a sort of resource perspective. Okay, the answer to that is the testing in production line of thought. So you do the best you can, and it's certainly better than zero. You can test a lot of things component-wise individually. You can do various integration and end-to-end tests. You are right that there is no system in not production that is the same as production, either in size or scope or whatever. And so that doesn't mean we should throw up our hands, but it does mean that we should figure out ways to roll things out into production safely. And so you had mentioned canary deployments, that's absolutely one part of it. Feature flags are another. So you kind of layer those two things together, and you can get a lot of safety. You can't guarantee 100% safety ever, but you can minimize the blast radius of the things that you change. So those are techniques that are hugely valuable. And then I lost the other part of the conversation, but we can talk about that later. Yeah.
Extending the same question. So basically, right now we have a big monolithic application list, like 15, 20 years old application, and pretty much we are trying to do the same. So the problem right now is we are running into a problem that the release management, where we say, okay, with these services, these are going to be the artifacts for Jenkins, and this is how the pipeline is going to look like. And for these, this pipeline, these artifacts, these are the things we are going to make it part of the release. So the documentation is a default back, or the release pipeline, they are just putting in the artifacts, just like putting the artifacts, the ones. So it's like they're not putting in the right artifacts. It's like a bit of a resource problem, but there's just so many artifacts they have to deploy, they kind of just fumble on those artifacts. Sometimes they just put in the wrong artifact because there's just so many artifacts they have to deploy every time the release has to go out. So what are the best practices to bring all these stakeholders together so that the mess is wrong, like far less. It's less error prone.
Yeah,
and you
sure.
can really reap the benefits.
Yeah, sure. I mean, honestly, the flip answer is backward compatibility of interfaces solves your problem. Why? So if you are having, I'm not sure, so I'll try to state back what I think the problem is. I think the problem that you're saying is I have to deploy all these 10 components at the same time in order for it to work. So by that nature, you have said that those 10 components, if that's true, those 10 components are coupled to each other in a, I say, unhealthy way. And so if you have to deploy them all as a unit, that means they're actually not independently deployable, which means they're not backward compatible. Does it make sense? So what you want to get to, I mean, the goal that you want to have, I know that you're not there, but the goal that you want to have is any of those 10 can be deployed at any time. And in order for that to be true, it means that it has to be safe to deploy them without deploying either the dependencies or, in either direction, right? People that I depend on or the people that depend on me. The implication of that is, again, forward and backward compatibility of the interfaces. Does that make sense?
I see what you're saying, but finding that pure, deep point where I say, okay, now they are purely isolated. To get to that point, that's
hard engineering.
How you kind of find, that sweet spot of it.
It's
now
hard.
They're totally isolated.
I get it. It's hard. That's why we have. That's hard. I mean, I get it. If it were an easy solution, nobody would care about this stuff. Because we just install the microservice conversion tool and we're all done. and the answer is sorry, that doesn't exist, right? You have to think about it because coupling is hard, right? We couple them together. It's easy to couple, it's hard to decouple, right? And so you are so not alone, and you have the system is built up over time, organically, things are coupled to each other. And there's going to be a lot of hard work associated with decoupling them. And you start with one, and you kind of, make that one independently deployable, and then you move on to the next one and move on to the next one. And it'll take a while, but once you do all that work, the benefit that you get out of that is now any of those 10 services are deployable at any time. Yeah.
So then at the very start of your talk, you mentioned that we don't need to discuss the Googles and the eBays because they're working on a totally different scale. So after
I'm happy to discuss them. It's just they're probably not applicable unless you're at Google or eBay scale.
Yeah, but then I guess, so what's the point at which you start to need to consider some of the things that they consider?
Yeah, we'll get there.
Yeah, okay, thank you.
Yeah, sure. And by the way, so my name is a rare, Randy's not super common, Shoup is super not common. So if you just Google my name, you'll find a bunch of presentations that I've given, and there are a number of them where I talk in more detail than we'll have time to say today about what it's like to work, what's like to build a Google or eBay style or size ecosystem, what it's like to work in there. So if you are interested in those, that information exists in words that I said. I wasn't going to say them today because, again, this is more about making that choice at an earlier stage. Does it make sense? So the mistake, I'll say openly, the mistake that I made, or the impression that I made was Google and eBay did this thing, and people are like, oh, therefore I should do this thing. No. Google and eBay do that thing. You might, if you are not Google and eBay scale, you should think about something else. And that was the genesis of this talk.
Yeah.
Okay, so let's talk a little bit about what it would take to be successful in microservices, and then we will talk about how to get there, or how to make that transition. Okay, so the first thing I would say, and I mentioned this a little bit before, even when we were in the monolith, the idea of being able to do continuous delivery is really a prerequisite for being able to get the benefits out of microservices. So what you want is a repeatable, some kind of deployment pipeline that allows you to repeatably deploy things, that's low risk, that allows you to rapidly release new things. If something doesn't work, you can rapidly roll back and recover from it. As a prerequisite for that, or as apart from that, if you've read or thought at all about continuous delivery, obviously automated testing is a huge part of that because you need to make sure that the things you're deploying are safe, and it gives you the confidence to break things and to make risky changes. And then there's also a continuous integration element of it where, so I've tested my individual components, but I also want to test things that are integrated together. And once you have that, now if you don't have that, the benefits of independent deployability of the services are going to be really difficult, right? Because if it takes a month to deploy a service, you're just not going to do that many of them, right? That's super painful. So I think that's one prerequisite that I've seen for being really successful. Okay, so another one is around organizations, and when we talk about organizations that sort of can't help mentioning Conway's Law. People familiar? I'll talk about it, but have people heard of Conway's Law? A few people? Yeah. So Melvin Conway in 1968 made this observation that in software organizations that he was familiar with, the organization tended to constrain or determine the architecture. So in particular, the design of a system built by a software team or set of software teams is going to reflect the communication paths within that organization. So he meant that as a descriptive thing. Like, he looked at organizations and said, that is what I see. But we can also use that in a kind of a normative way. So if we would like to build a modular system, then one of the prerequisites that we have is maybe we should make our organization modular, and then from there it's going to be a lot easier to build a modular system. Can sometimes feel a little bit counterintuitive, but maybe this will give you some insight. Like, if you have small independent teams, that's going to tend to lead to building those individual components that are themselves isolated from each other. But if you have really large, like 50-person teams or 100-person teams that are very interdependent, where there's not these clean team boundaries inside them, that's going to lead to much larger, much more monolithic systems. Does that sort of accord with people's experience a little bit? Yeah. And so to get the system we want, we need to engineer the organization sometimes. So I like to talk about these teams as service teams. And so this is the way we're organized at Stitch Fix. It's also how Google is organized, Netflix, et cetera, Amazon. Teams align to specific domains, solving specific business problems. So there's a clear, well-defined area of responsibility for the team. They typically maintain a single service or application or a set of related services. Those teams typically tend to be cross-functional, so they do both, the user interface such as it is, and the back-end things, and any of the business logic. So the team has inside that boundary all the skill sets that they need to build the service or build the application. And again, as we mentioned before, like, they'll be layered on other teams, like maybe other teams that are at Stitch Fix or like a cloud provider. Like, there are always other things that those teams are going to use. And then those teams have, in the best organizations, have end-to-end ownership of the things that they build. So the team owns the service from designing it to deploying it all the way through to retiring it. And then in all the companies that I mentioned, there's a very sort of DevOps philosophy around the same people that build the software are also responsible for operating it. Does that make sense? Cool. Okay. And so another aspect of sort of operational maturity is around monitoring. So if you think you have lack of visibility into your monolith, wait till you break it up into 100 pieces. It's really going to be confusing. So it's really important to get good at monitoring before you start to build out a distributed system. So having a strong practice of monitoring your production systems in a very disciplined way. The problem you're trying to solve is you want to be able to detect and alert on issues that occur in the system, and basically, you know that you're successful if you can do runtime diagnosis remotely of the systems. Does it make sense? Like there's sufficient logging, monitoring, metric collection, distributed tracing, all those things. There's sufficient of those things that I do not have to be on the box in order to understand what's going on. So as I like to say, if you ever have to SSH into a machine, you didn't build your monitoring properly, right? There was a surprising, I will not out the company, but you would be shocked to learn that a company last week said, oh, I have to attach a debugger to this thing that you guys are like, no dude, you super do not. And you should be fired given the place that you work at, but I won't share who that is. Yeah, that was pretty frightening. Cool, okay. Does this stuff make sense?
Can we get a presentation after this?
Of course, I'll absolutely share the presentation. In fact, it's already, if you go to my SlideShare, again, Randy Shoup, super uncommon, slideshare.com/Randy Shoup. A version of this is already up there, but I'll happily share it through Jerry, whatever mechanism, I'll make the PDF available, sure, yeah.
So,
Quick, yeah, sure. Oh yeah, sorry.
if you have to SSH into everything, then where do you go from there?
So I don't want you to SSH into anything.
So currently our situation is you do have to SSH into everything.
Oh, so stop doing that.
Just let it burn.
No, and it's a game of inches, right?
Yeah.
Why? I mean, and I'm not challenging you. Like, you ask yourself why. Like, I don't understand what's going on with this. I have to SSH in and like look at the logs on the machine. Okay, well, get those logs off the machine, or
Job
right?
security.
I mean, job security. Please don't ever do that. All right, I'm not super PC. Like building crappy software is not job security. It is not. Maybe if you work in a toxic organization, you can live for a while because you have built crappy software, but the end result of that is not retirement. Well, the end result of that is not retirement after decades of doing the same thing. The end result is you not working there, or more precisely, that project being canceled because there's some other way to do the thing that's properly engineered. I just never, I mean, I know that's a joke, I know you meant it as a joke, but like, I don't have it, I know you wouldn't do it, but like, that is, some people believe that, and like, that's not a thing. You can only get away with that in an organization that does not care about what you do. Right? Because if they care about what you do, they're going to fix that problem, not with you. Yeah. Okay. Cool. So now I promised that we talk about the deciding part. So these are sort of the criteria we use to decide to re-architect. So why would we re-architect at all? I typically see 3 different answers, you know, and they're not mutually exclusive. Often they're a combination of all 3 of them. But the primary one that I see tends to be around velocity. So why is your monolith bad? Oh, it takes us so long to do these things, right? It takes us so long to build a new feature, to test things in an integrated way. So it tends to be like time to market and feature delivery for the business. That is the reason why you would break things up. Does it make sense? Yeah, does that accord with people's experience? Yeah. And the other, you know, so the failure modes or the, you know, warning signs are like teams are constantly stepping on each other's toes in a common code base. They're not able to develop independent, even though conceptually they're building independent things as a practical matter, they're not able to develop them independently. And then the other related warning sign is it's super difficult for new engineers that you bring on to be productive. Right? If you can't trust a new engineer to deploy the software for months or be on call, like that's a warning sign that things are just too complicated, and if we broke them up into smaller pieces, it might be better. So the other obvious reason is a scaling reason. So this was absolutely why eBay broke things up into smaller pieces. Just simply the vertical scaling of the monolith just wasn't working. And so parts of the system often need to scale at different life cycles. Does it make sense? Like some parts of the system need to scale really wide, really quickly. Other things are much slower growing, or like are not, do not scale with number of users, or does it make sense? Like they scale on different axes. So that's another reason. And then a third reason, which usually, I've never seen this honestly be the primary reason, but it's almost always a secondary reason, which is the ability to do independent deployments like we were talking about, right? Parts of the system need to, again, have different life cycles, and so parts of the system need to deploy independently of others, and that monolithic, just simply building and testing that monolithic release takes too long. So once you're at this point, you might go, oh man, we have to re-architect the system. Well, you know, the way I like to think about it is getting to re-architect a system is actually a sign of success, not a sign of failure. Why is that true? It's because somebody cares about what you're doing, and we have the resources and are willing to devote them to the re-architecture. And neither of those things, you don't magically get either of those things. Does it make sense? Like, there's no guarantee that a thing you do anybody cares about. Like, we should feel good that the thing we're building somebody cares about. Hopefully lots of somebodies, you know, that pay you money. And then the other aspect is your organization has sufficient resources to do a re-architecture, and they are willing to invest those resources in the re-architecture. Does it make sense? Like, so it's really a sign of success rather than failure. And you can see that I reassembled this from other slides. I'd said this before, but again, it's the same idea. Like, if you don't regret your early technology decisions, you probably over-engineered. So that's about the sort of deciding to re-architect. So now I could do questions on that maybe, and then we can talk about some tactics around, okay, now we've decided to re-architect, what are some techniques that can get us there? Yeah.
So when you re-architect, is the focus more on packaging and kind of making things independent, kind of break the noodle soup?
Versus really look at potentially architecturally, going to more kind of horizontally scaling components, because you can certainly break a monolith into individual kind of smaller deployment sub-components and still have the underlying architecture still be the same, as opposed to really drastically going with maybe kind of a more distributed Hadoop, Kafka, whatever the needs are, as opposed to more vertical components.
You ask, am I trying to get individual components, or am I trying to get horizontal scaling? Probably you're trying to get both, to be honest.
See, because if you're just breaking the packages, I'm assuming that's a little easier to do, independent packages, as opposed to underlying architecture itself.
In different packages. Well, if you no matter how many pieces go into it in your build pipeline, if you're still deploying one thing, that's a monolith. We will talk about this in a moment, but like cutting a slice or a seam through a monolith, whether horizontally or vertically, all those are hard. And that's why people are here interested in the techniques, because it's not easy. It's doable. Every place that we mentioned, the eBays, the Twitters, the Amazons, they've all done it. So it's certainly possible. There are existence proofs. But each of them invested quite a bit of effort into it. And so don't hear me say you should live in some horrible monolithic world forever, but you really have to recognize that there's a big investment that you make in breaking it apart. Once you have finished that investment and made it, you're going to be very happy, but you have to kind of be up for it. And you have to have all those prerequisites as well, right? Like if your organization isn't set up to do it, it won't work. If you're not able to monitor your system, your new distributed system, that's not going to work. If you're not able to release things on a regular cadence, it will work, but it won't give you the benefits that you want. Does it make sense? Like, oh, I've broken these things up into 10 services. Yeah, and it takes me a month to release each of them. Like, okay, sorry. Like that, you had to solve that problem first. Yeah.
So from your experience, is there like a certain size? Is that like a certain size of the company, maybe like engineering team or number of lines of code where you typically would see that there will be the tipping point that they really need to do this?
Yeah, that's a good one. I removed that slide, but I don't think there's a magic formula, but I will give you some thoughts, because I've thought about it a lot. When you are a 5-person startup, like whether that's in a bigger company or you're actually a startup, like that's one team. And that's probably one service. That's very natural. So it's obvious. Like when I have the 5-person startup, like, okay, we're about to do microservices. Like, no, please don't. And have a business model, have product market fit, make some money, find some customers, and then you can, come to me in a couple years, and then we can talk about microservices. I'll still be here. And then by contrast, when you are like a 100 or 150 person organization, if you are not broken up into smaller teams, hopefully that have individual deployment units, that's going to be hard. And people are laughing because you probably live in those worlds. You're laughing because it's hard, right? Yeah, so that I would say that 100 to 150 person organization, if you're building one thing, that's challenging. It's totally doable. If, again, you are disciplined, you're building it out of smaller components, et cetera, but that's challenging. So the question you have is, well, what about the middle? Like, that's fuzzier. What I have seen in organizations is that there tend to be stable points at around everybody fits around a conference table, so they're around the 5 point. There's a stable point I don't know why it's true, but there's a stable point around 25. So Stitch Fix was at 25 for like a year. And a bunch of other companies that I know are in that kind of, there's a plateau at that point, it's stable. I'm not sure I understand why, but it's true, observationally. And then seems to be another stable point that's around the size of a small town, so like the Dunbar number, 100 to 150. And then once you're beyond that, it just keeps growing pretty regularly. And so yeah, I like to say the trough of productivity is around that 25 number, because you are too big to be one team, healthily, and you are too small to have permanently staffed other teams. Does it make sense what I'm saying? Like when you're 100, 20 teams of 5, like there's a lot of work those individual 20 teams can do, and you're not needing to like play a shell game moving people around. And so people are able to stay in those teams for relatively long periods of time. They can develop those deep knowledge in that particular area, and fortunately we're in that area in Stitch Fix. But when you're 25, that is challenging to do, right? Because 5 teams of 5, it's hard to have enough, you rarely get lucky that the work that you need to do distributes itself so naturally. Does that make sense what I'm saying? Yeah, so I have lots of thoughts about that. I mean, the quick answer to those thoughts are, I like having teams be permanently around particular areas, but the 25 number is where it's hard to avoid forming project-based teams. I don't think that's the best thing, but I think it's the least terrible approach to that size. Anyway, does it at least make sense what I'm saying?
You kind of match with my experience.
Does it match your experience too? Great,
25.
thanks. Yeah. That's the area where that's where it is a stable point, and I wish it weren't, because you kind of want to be smaller and more nimble. Anyway, that's life though. Yeah.
How do you measure success when you start and you want to build? Is it by the number of services that you're building? Is it by the number of services you're building? Is it by basically breaking it out into services that are really independent of each other? How do you measure success?
Yeah, that's a great question. I'm flip and punchy. Do we measure success at how many lines of code we write?
That's not exactly what I didn't want to hear. Is that basically?
No. That's not the answer.
Yeah.
That's why I asked it in that way. So I don't think number of services is super helpful. Is it better to have 150? Not really, not necessarily. Maybe. But I think you were getting more to the answer at the end, where let's say it this way. What problem are you trying to solve? You're trying to solve the problem of feature velocity. You're trying to be able to deploy new features for your business faster than you were. That's a metric that actually matters. Okay. You need to scale the system to handle the load. That's a metric that actually matters. You need to be able to deploy independently. That helps those other two, if that makes sense. That's a metric that matters. The number of services or number of teams isn't a metric that matters to me, right? That's an implementation detail. You are doing your job as engineering leader when when you're in engineering leadership community here. You are doing your job as part of this community of engineering leaders when you deliver a good cadence of features to the business, and you are able to scale your services and your infrastructure to meet the load. That's your job.
So ship faster is actually
ship faster and don't go down.
Not really ship fast. I guess from many
ship more value.
Yeah. From many experiences, basically, when you see everybody productively busy and balanced, that means your team is healthy. But if at the moment they feel that, or somebody actually feel that less work, keep asking for work, or feel boring, there's some point that it's not good. So you need to adjust that a little bit. I mean, I'm just purely looking at it from a management point.
Yeah, and it's fair to look at it from a management point. My management wants me to ship faster. Yeah, dude. That's your job. But it's not. But again, to your point, and it's a subtle one, or it's a nuanced one. it's not, oh, I shipped more, I did more releases. Like, that doesn't matter. What matters is that I shipped more value more quickly, right? I mean, and again, that's a little bit hand wavy, but like that's the actual goal, right? The goal is for us to deliver value to the business, to our customers, more quickly than we were able to do otherwise. And that the solution to that implies a lot of these other things. That the continuous delivery idea, it implies breaking up into smaller components so I can, release those independently, and it implies, it implies a lot of stuff.
So can I ask you about how do you define your value?
How do I define my value? Well, it's going to be different for different organizations. Overall, Stitch Fix, and I can't really share you any of the actual numbers, but we look at the overall revenue of the company, as every company should. We look at the happiness of our customers, which we actually know because, again, we ship those boxes, and every time you receive something, you keep some number of them and return some other number, and we would like you to keep more than otherwise. And also, we ask very explicitly as part of the feedback, were you happy with, we call them fixes, were you happy with the fix that we sent? And 1, 2, 3, 4, 5, or whatever, I forget the number, it's either 3 or 5. And like that metric really matters, because that is your leading indicator of everything about like Net Promoter Score, like everything about customer happiness, is either reflected in that number or derived from it. Anyway, so builds up to it. So yeah, those are the things that we care about. But your businesses are going to be different, right? Like a bunch of your businesses are B2B, and so it's not going to, you don't have like that same, like, how happy are you with
we're dealing with the
ERP
customer.
system we gave you? Like, I don't know.
We should say the customer
Customer satisfaction. Yeah.
I want
Turn it on.
I want to understand in terms of the team composition and how to get the best velocity. So for example, if you have a bit of functional teams and there's a team which you have like full stack teams. So so it's not a very big company, so the functional teams, they get their primary, they make the services out of those. They get shipped to internal, the full stack team, they start making the full feature stack out of those services. And then you kind of get some bugs. Now you should go back to those teams to look into those. The full stack team, they should take the ownership of those services. I know you should abide by the contracts, but still there are a lot of things you kind of go deep, and then that's going to affect the velocity. It should be kind of ping pong style. What do you think? What are the best practices? How you should overcome so that you can still achieve the best velocity? And because one thing in consideration is there's not a lot of work in the company. The feature team, they're making those things, but it's not like they have 100 features they have to work all day. They will still run out of work. So it's like how you can keep everybody busy and still get the best productivity out of it.
Yeah, I feel like there's a lot of context specific to your business that is part of the question. So it's a great question, and also I will not give you a good answer because I feel like you would, in order to give you a real answer to that, we should talk more about what the context is, because you made this distinction between a full stack team and a functional team, and I feel like I have to explore that a little bit with you to figure out. I mean, I think I know what you mean by that, but that's not how I would have organized it, to be honest. So yeah, I mean, when I think at Stitch Fix, all teams are full stack teams. Now that does not mean everything has a UI, right? But every team has all the skill sets that they need to do their thing. And again, this might be just terminology. We don't have functional teams. In other words, we don't have like the DBAs versus the ops people versus the QA people. But we do have teams that build and offer services. And so, yeah.
The consumers of the services as well.
Pardon?
They are also the consumers of those services.
Every team offers services. Pretty much every team offers services or an application, that's used by end users, and are also consumers of. Most teams are consumers of internal services. The lowest level is a consumer of like cloud services from other third parties. Yeah. So I'm getting the 10 minutes left. So we can keep doing more conversation about this. That would be great. Or if you want to hear a little bit about architecture tactics, maybe we could do that. All right. Seems like that's a consensus. Okay, and I do have to make my flight, so thank you. Okay, so re-architecture tactics. So the one thing please do not do is a big bang re-architecture. We're like, okay, we're gonna stop everything for 6 months, but really that's 3 years, and we're gonna do everything. You're laughing because that's often how it's done. Please don't. So Martin Fowler of refactoring fame, totally awesome and wonderfully sarcastic. The only thing a big bang migration guarantees is a big bang. Totally true in my experience. It is the rare big bang re-architecture. I have never seen one succeed. If you tell me that one succeeded, I suspect that it actually succeeded because it was incremental. And that's the way to do it. So I strongly believe and have implemented multiple times at several companies this approach. And some of it's going to be obvious and some of it's going to be kind of not counterintuitive. So the step 0 before you decide to re-architect from my monolith in whatever language to my microservices in the same or a different language is pilot the new thing. And what I don't mean is prototype. So we could do that as step -1. But pilot, and what I mean by that is build a thing that actually matters to your customers in the new way. Why should you do that instead of building a prototype? The prototype is a toy, which you're explicitly going to throw away. And that's a technique to have in your toolbox, but I do not feel comfortable moving to building, we're going to re-architect in Haskell. Like, we should build an actual thing that customers actually use in Haskell. Does it make sense? And it can be a thing you've already built and you rebuild it in the new way, or it can be some new thing that you want to build, but you build it in the new way. Why do you do this? It's an opportunity to learn. That you are this is lean startup, right? You are front loading all the learning about the new way of doing things. But you also, do not underestimate this one. You are demonstrating that this could actually work in your environment with your people. Does it make sense? You are demonstrating the feasibility and you're gaining confidence. You might be super convinced, but like there are other people, I guarantee you, in your organization that are skeptical about that, and you have to be able to gain their confidence and demonstrate feasibility to them too. Also, why do we do the pilot instead of doing everything all at once? Is that it might fail, and so you want to bound your investment and your risk, and you also want to learn as much as you can in that safe environment, and then you apply that learn, one time, and then apply it more broadly. Does it make sense what I'm saying? Cool. So step 0 of that pilot. And that initial step is the hardest, like it really is. Why? Because you're learning how to do things in a new way, and also all the supporting capabilities that you might need, you're going to have in one form or another to get that first thing out. But that's valuable because it forces you to do that. It forces you to do something real. Okay, so now the next steps are incrementally migrating the next sets of your monolith or your system or whatever. And this is the counterintuitive part. This is what we did at eBay. We were rebuilding everything from that monolithic C++ thing into Java. And what they did was they basically looked at all the pages on the site, looked at what the revenue contribution for each page was, and reverse sorted it. So the highest revenue contributing page was the top one, and they started with that. And they were able to, there was enough resources, so we were able to do a couple in parallel. So maybe we did like the top 3 revenue producing pages first. So why would you focus on those rather than the easy things? Because those actually matter. Does it make sense? Those things actually, in the eBay case, it was sort of the selling, the actually end part of the selling flow and some of the critical parts of the buying flow. And you focus on those areas have the highest business value. So the ROI, the return on investment of investing in those areas, even though they're hard and challenging, the ROI is the highest if you do it there. And you want to focus on the areas that have the greatest rate of change, right? If that area is already changing really rapidly, then moving to the new approach is going to help you. And so if you do it this way, well, you might think that you have, somebody in your organization might think that you have an infinite amount of time and resources to put against this re-architecture. That is not true. You have some finite number, whether people have thought about it and are disciplined about it or not. So if you do the highest ROI things first, when you exhaust that finite amount of time and resources, you have done the most important things. Does it make sense? It's like, this is just like prioritization 101. So you maximize the near-term payoff from the fixed investment that you're gonna make, and it also forces you to kind of solve all those hard problems. So you can imagine doing it the other way, where you're like, let's do the easy things, and then 2 weeks later we're gonna do the hard thing. And you're like, the easy things are really easy, and then you get to the hard thing, and you're like, oh my God, that super doesn't work. Back to the drawing board, like, right? Like, oh, the messaging system doesn't scale to this thing. Oh, crap. So it's best to kind of learn those things ahead of time, and then you can readjust when you have time. Does it make sense? Yeah. Would you mind if I why don't you hold the questions till the end, and then hopefully we'll have some more time. Okay. So one implication of this is if this re-architecture is carving up a monolith, that residual monolith might still live forever. But the parts of that monolith that are living are the parts that nobody cares about, right? And this was absolutely the case at eBay. So even we started this migration before I got there in 2004. So probably 2002 they started the C++ to Java migration. Most of it was done the vast majority was done by like 2008. But there were still pages that were on that C++ thing, even in 2011 when I left. But they were the pages that like nobody cared about. And they never changed, they totally worked, they were super simple. It just, what the ROI for converting them just wasn't there, and it didn't matter. So that's cool. Does that make sense? Yeah. Okay, probably last thing, and then we'll do some questions. So some techniques, they're very simple, but some simplistic techniques around carving up a monolithic application. So you want to look for a seam in the monolith, some place where you can kind of cut an interface boundary and block off, some part of the system from everything else. And by the way, finding that seam is often the hardest part. Like that's the thing that I wish the microservices migration tool existed for, because this is the hard part. So you find that seam first. Now you wall that seam off behind an interface, right? So whatever programming language you use, or whatever programming environment, you make an interface out of that thing. Now you do not skip this step. Write automated tests around that interface. Why? Because you're going to move it, and you want to make sure that that moving doesn't break it. Does it make sense? And if you don't start here, you're never going to write the tests, and just please stop. Because you want to write tests there. So now, only now that you have written those tests, you can replace that in-process implementation with a remote implementation. And then just keep doing that over and over again. Now, even though I've said this 10 million times, it still seems a little bit simplistic, but I guarantee you that every migration that I've seen that did not do this failed, right? And it's pretty conceptually it makes sense, right? And again, each of those individual steps, they're hard, right? Finding the seam, wow. Cutting the seam away from all the other spaghetti code, that's hard too. All those things are hard. But if you don't do it, you're never gonna finish. A resource that I cannot recommend more strongly is Michael Feathers' book called Dealing Effectively with Legacy Code. Michael Feathers, Dealing Effectively with Legacy Code. When I joined Google, there was one book that was required reading for everybody who joined Google. That was it. Michael Feathers is totally awesome. If you have tons of money, you can have him be a consultant for you. He's great, really smart guy. He's been doing this exact thing for 10 or 15 years, and he's brilliant, and he's able to come in and help in lots of different ways. But you can also read his book and get a lot of the benefit just from there. Anyway, that's a really great resource, because it's a lot more detail behind all of these ideas, right? This idea of a seam, that's his word. And so I borrow it, very openly and shamelessly from him. But part of the book is to help you figure out, give you some techniques for finding that seam and sort of exploiting it. Cool. So we're sort of out of time. Maybe we can do one or two more questions, but yeah.
So hopefully, quick question. Back-end splitting the services, totally clear. What about front-end? How do you split that into microservices?
Yeah, so how do you split the front end into microservices? That's a great question. Microservices isn't a great word, but it's the best word that we have. I think dividing the front end into mini applications or micro applications is another applicability of the same thing. So I wouldn't, anyway, that's the answer. And the wonderful thing about the web is like you can naturally stitch things together in a very clean way. If you're talking about building an app, like now the app is a monolith, and so now building that app needs to be built out of those individual components. There's kind of no way to deal with it otherwise. But yeah, if you're on the web, yeah, you can just take slices of your monolithic app and make it, little subparts. And that was that first thing that eBay did, if that makes sense, right? They took the monolithic everything about eBay in one place, and they said, okay, well, the selling part's here, and the buying part's here, and the search part is here, and ... But yeah, but the same techniques, honestly, that you would use. I mean, I'm a back-end guy, but also the examples are kind of more obvious with the back-end, but the same techniques apply to the front-end stuff too. Yeah.
So that's sorry. I'm quite distracted. So let's just take maybe 2 more questions, and then we'll.
Yeah, great.
And then Randy will be here for a few more minutes.
About another 5 or 10 minutes.
Yeah.
Go to the airport. But yeah, sure.
So this is kind of a newer player in the field, but I'm just curious how serverless or function as service fits in with monolithic, and it should be considered or where.
Oh yeah, great. So how does serverless deal with how does serverless fit in? That's a great question. Yeah, so that's why microservices, like, there's probably a better phrase, and I'm making this up right now, but like distributed componentization, or I mean, there's some better, more generalized phrase of which microservices is a specific instance. I think I'm very excited about serverless. We have yet to put that into practice much here at Stitch Fix. That's not because it's not a good idea, but because so far we've had more fundamental, like we haven't had problems that only that solves. Like we've had more fundamental, like extracting things from the database and from our applications kinds of problems where the traditional techniques work well. But I love the idea of the function as a service is super powerful. It comes into play, so again, if you're not bored of me, you can look at some videos and other talks that I've given on what are called, managing data in microservices. And one of the techniques that you can use, this is probably too long an answer, but I'll give it anyway. One of the things you want to solve, one of the things you like to have in your monolithic database is the ability to do transactions. You cannot have transactions when you have divided everything up into smaller services. Don't ever do two-phase commit. That's the anti-availability protocol, as Pat Helen likes to say. But you can do something called a saga, or like a workflow, which takes this transactional thing of like, I want these 3 things to all happen, and they don't happen all at once, atomically, but they would happen maybe in succession, and connected by events. Okay, I see you nodding, so I haven't lost anybody yet. Serverless is a wonderful tool to have in your toolbox to implement that. Does it make sense what I'm saying? So let's imagine you're doing a payment processing workflow, which like there's no payment processor that does a distributed transaction. I will just let you know that. People are like, oh, I work in finance. Like I have to have two-phase commit. Like, no, you super don't actually. Nobody does that in finance. But what they do is a workflow. So when I want to pay you via PayPal or credit card or whatever, like there's no distributed transaction that sucks money out of my wallet and magically puts it into yours. You laugh, but like think about it. Like that's what we're asking of every other part of the system. Like, oh, well, we have to take it out of Randy's pocket and put it in Patrick's straight away. Like that is not how the real world works, guys. They take it, it goes out, it kind of gets reserved out of my thing, and it goes into a clearance. I don't even know how it works, but like it takes. All I know is it takes 3 days. I don't have access to the money. It takes 3 days to get. Patrick doesn't have access to it, but like 3 days between Randy and Patrick and the banks. There's a reason why the banks have billions of dollars. Because yeah. Anyway, so serverless is a great. They don't use serverless, but they should. Serverless is a great tool to use for that type of thing. Okay, maybe one last one and then we can be done. Maybe someone who, yeah, sure.
So I just want to add on to legacy code. So you called about Michael Feathers, right? So how do you define legacy code? He says it's a code without tests. I think you rightly call writing automated tests as important as before you dig into the code.
Yeah.
That's the definition, right?
Yeah, the other flip definition is legacy code actually works or actually runs the business. Yeah. Cool. Hey, thanks very much for coming. We're happy to host everybody.